All right, and starting on data collection, looking at this in general, we see that we get 1,627 legendary parts of copper at 2.7 items per minute. So the first thing that's going to tell us is that when we invest in this at level 0, we best be doing it for low density structures and not for copper plates. The same's true with steel. And that's all because we're passing it through these buildings. It's actually surprising how bad this is for steel, considering we're using 2 items of steel to make a part. Maybe we'll get better out of a different build. If we look at the wiki's suggested build, though, we're just not seeing that. Over 10 hours, the amounts of LDS we're producing is comparable, but if we look at fluids, it's a bit different, because we're making 6,000 fluids off of an efficient recipe versus about 8,000 fluids and 2,400 molten iron that we could use as a benchmark. And then this looks really bad compared to our normal steel processes. Right? Because with barrels, we were doing so much better. When we look at items, we're making a huge amount of items in comparison to these other builds. But that's half as many steel plates as we'd normally get. That suggests that this process isn't great for making items. Maybe when we do analysis and scale everything up to say, well, what if I had a build that used 8,000 fluids, like my novice benchmark here? Maybe we'll see different. It would also be an interesting thought experiment to say how many low-density structures this would produce. When we look at our production methods where we do LDS from the get-go, we see a result. We're making almost 100 more LDS out of this, and a lot more copper plates. We can't minimize fluids, but we're still going to be spending less overall. On this 2B1 in particular, though, it appears there was a mistake made, which I've deliberately left uncorrected. And that's that we're only making 1,500 fluids on this one. But we could scale up these copper plates by 3 times, and maybe a little bit more, to get it up to 4,800 fluids and compare it to our other production techniques. If we did that, we're making at least as much copper plates, probably. Maybe more. This shows some promise for the analysis step. The corrective step is going to be to apply more fluids to it and attack a build with that. With the idea of just using quality modules in here, that shows less promise. Because we're making less copper plates, less plastic bars, less of everything, basically. So this does appear to be a scenario where if we select a production strategy, like using these quality modules and it shows promise, we want to use that strategy all the way throughout a build and to the maximum extent possible. Coming to the end of our 10-hour run, so these will stop moving pretty quick here, but even looking at the end, we can see that things are really going differently once we invest in research. Of course, it's exaggerated because we invest up to level 15 all at once. In reality, it's going to cost 437,000 researches, with one planet making metallurgic science packs in order to get it to this level. I'm using processing unit productivity 15 as a proxy. As far as how doable this is, if you're at 100 items per second science, this takes you about an hour. Seriously, you'll be making 360,000 science per hour, and then you can multiply that by productivity if you have the right productivity modules, and that will put you over on its own. If you have a different kind of lab that only occurs on Novice, by putting in a good effort, then it'll happen about somewhere between 2 and 4 times as fast. In short, this effort is doable. So I'm going to let this run for a second more before I call this my final investment. On this run, I've gone in and let me see, where was the one which was a little bit broke? Yes, that's gotten fixed as best as it can. I say as best as it can because we're saturating this build with copper, and it's taking 4,300 instead of 4,800 in order to make this production run. If you look at these units, you'll see that we're using significantly more of these. Another thing to note is that while our strategies do grow proportionally, and I believe it's going to be about 10 times when I go to do final analysis, I'll get a better quote on that because that's my memory of what I saw on this run. But we're seeing a really huge increase here. All of a sudden, we're getting really good values of steel, but on Novice C, we're still at sub-item per minute on LDS, even though we're getting a huge amount of copper plates. And in comparison to everything else, that's simply knocking it out of the park. So when I saw this, that motivated me to change these builds to use the item strategy where possible. For science, I didn't use it on the 2C build, but in general that change was made because I thought it would better represent what these builds were capable of. In most cases, this appears to be proportional when I look through. So if we go to Novice A and then look at Novice B, we're still seeing a similar relationship of LDS production being acceptable to slightly less due to using less fluids. And if it were scaled up to use the same amount, it'd probably overtake it. We've noted what happens with Novice C. Nothing particularly stands out with the rest of the builds that we're looking at, although this does seem to have fallen. You have to remember that this run is doing a proportional amount of work to 8,000 fluids when it's using 4,800. In our corrected build, the same is true, and it's even using less fluids. So this technique here is actually very powerful. And our 2C build continues to lag, so that continues to motivate us to just focus on a strategy. Alright, coming to the end of another 10-hour run, this time at research levels 22. This is saying 11 million for the next research. This is saying 7.4 million. So at this point, you want to have a 100 IPS line combined with a biolab with full productivity in it, because this will take you hours to buy just this level and hours to buy the intervening levels if you're playing this game at this point. Obviously, when we go to 30, we're going to have to significantly upgrade our science line to be in excess of 1 million science per hours, because we're jumping hours going to just this research. An interesting pattern begins to emerge when we look at this line as it runs. And that's that we make more LDS than we do steel using the common sense approach of doing all quality modules. In terms of materials use, this isn't the most useful or effective strategy. It's just a unique pattern, I think. Because if we look at our B line, we're making just about as much LDS, but it would be for less fluids, and we're getting more raw materials out. So think about your life choices. In terms of items, if we pursue the item strategy, we get a huge amount of copper plates. It's great, but a very small amount of low density structures compared to everything else. So looking at our B line, that's 175k versus the 312 to 313k we're making there. It just is incredible, right? When we compare this to our other strategies, it depends on the strategy. Because all of a sudden it's looking like it was a bad idea to invest in this line, right? Oh, something's running in the background, slowing my game down. Anyways, when we look at our novice B strategy, though, the one that uses 4.3k a minute instead of 4.8k a minute, it's massive. So it's a situation where if we do it right, we see value throughout the lifetime of the assembly line, and it's a great thing. At least up to level 22. If we pursued a questionable strategy, we get questionable results, because 2C still is lacking. And so that seems like it was a dead end. I don't mind. If I write off a bad idea, then I've succeeded in saving somebody some time pursuing that bad idea. Alright, last one. So on this one, I have to admit, I made a mistake, and I'm going to correct it in my data collection. I forgot to put in this filter. This created an interesting situation where this build overperformed. And When I noticed I made my mistake, I threw out all of my data and restarted these builds. When I went to demonstrate why I made the mistake and what the conclusions were, I noticed I could make as much copper plates per minute as an LDS build. You have to be very careful when you analyze this stuff. Do you see that spike there? So the way that that mistake manifests is you throw out all of the low density structures that this assembling machine 3 makes, which is about an item per second or more. So instead of recycling all the epic parts to better parts, I was accidentally recycling an LDS, and that took out about 100 a minute from this number, which is 117 a minute. And because I was always producing low density structures, if you look at a readout, it looks like you're always making 120 items per minute until you look at your consumption chart. So keep that in mind, and if you go to reproduce this series, that's a way that you can burn your fingers. I don't mind showing you the burns, I just want to make sure that I have all of my fingers and none of them get cut off. So that is the one oddity. This build still presents us with an interesting reality, though. We're making about half of a low-density structure in parts. 60.3 a minute. And then 151 a minute. 603 a minute. If you divide these by 60, that's 10, right? If you look at that, then 10 is half there, 1 is half there, 2.5 would be this number per minute here. What a fascinating thing. So that's an interesting thing to note. Because it's at 300% productivity, though, on this super duper expensive productivity recipe, it costs 191 million plus all of the other levels to get to this point. So you want in excess of 1 million items per hour to buy this machine. And this is where you can see 12 units operating, and if we slow time down to 1x, these are virtually always operating. There's some pauses. I know that one I caught had an item ingredient shortage, but it's not an often thing. And that's all because of this 300% productivity bonus here on these machines. That it's upgrading parts in this fashion. If you think about it, a half of an LDS times 4 is 2. And then we come to meet that with 2 more LDS. What that means is we're seeing the full 4 items per second coming from this build right now. And that's really what 400% productivity in total, 300% as a bonus, suggests. We're doing 4 times the amount of work and putting it into a machine that divides by 4. So we'll get an even amount out. Wow. So how do our other builds hold up to this? Well, (2A) is suddenly not looking so good, and that's part of the 2 series where we had those massive production bonuses. 2B, we're only doing an item per minute, and that's because we're losing about half of our selections at this point. What this suggests isn't that this is a bad recipe. What it suggests is that this will start performing this way with this module mix to a lesser extent, but 2 levels sooner. Well, not quite. This would be plus 50% productivity, so that's 5 levels sooner. We would need to get to about level 23 in order to start seeing this perform at that infinite rate, I think. Our level 22 analysis was just short of this thing's time to shine. For Novice C, since we're not producing that much LDS, it's rough. It has a place, the place is just not here. If we put it in any item build, this would shine. This would be great. For 2B, which was a consistent performer, we're producing less LDS than we should. However, we're putting in about half as much fluids. And we're still getting in massive amounts of plastic and steel. We're actually getting slightly more. So if we scaled this build up to full, it suggests that it would be a solid performer. And if we put in full modules throughout the build, then it should do even better. Is that the case with 2C? No. This suggests that we have to apply the idea consistently throughout the build to see the full benefit. Because on the basis of this copper, we would do well. It's just that if we compare that to 2A, we wouldn't do much better than what we have. It's just barely starting to shine now, when it was performing poorly before. And frankly, this one just performs better still and better consistently. Once we made the switch over to the correct modules for this level of productivity only, then we would expect to do very well indeed. And watching this, you can see that we have several machines activating down here. So that suggests this build has an incredible potential.